Now that we've learned to factor, we're going to investigate solving quadratic equations with this technique. Now, a quadratic equation in one variable is an equation that has a second degree term as its highest term. It must have that second degree term. Now, here's an example, ax squared. That is a second degree term because the variable is raised to the second power. The other terms are lesser in degree because the variable is not squared. It's raised to the first power in bx, and it's raised to the 0 power. In other words, it doesn't even exist in that constant term c. To make sure that we retain that x squared term, which is what a quadratic equation is about, we technically in the definition say that a can't be 0. So if a were 0, that x squared would go away, and we don't let that happen. So a quadratic equation must always have that x squared term. It can have, or it may not have, an x term or a constant term, but it has to have the x squared term. Now, one example of working with a quadratic equation in applications has to do with throwing an object up and that object, because of gravity, falling to the ground again. We looked at an example earlier this term of a compass accidentally being thrown upward and out of a hot air balloon that's at a height of 300 feet. You may remember this picture that I had. The equation that can describe the height of the compass in terms of time is given by this, h equals negative 16x squared plus 20x plus 300. This h stands for the height, and x stands for the time in seconds. So what we have here is a relationship between how long it takes the compass to fall and the height it's at. We could answer a question about this. In particular, how long is it going to take for the compass to fall and hit the ground here? Well, the height of the ground right here is 0 feet. So when we're answering this question, we're really solving the equation 0 equals negative 16x squared plus 20x plus 300. Notice that equation is a quadratic equation because of the x squared term. It's very similar to the one we had up here that was a general form because it's also set equal to 0. What we're going to find is that the technique we're going to use with factoring, it's really important to have 0 on one side of the equation because there's a rule about having a 0 product that is going to be very useful to us. So that's what we're going to look at next.